Thank you, everyone. So again, I'm Gidi Cohen, one of the founders and CEO of Skybox Security. If you wonder about my accent, you can guess, but it's an Israeli accent. So I apologize up front if it sounds a bit different. I want to give you a very quick background on who Skybox is, and then we'll discuss more about predictive technologies for cybersecurity. So Skybox is basically a software company, VC-backed, started 2002, headquarters in San Jose. Basically selling software primarily to large enterprises, banks, energy, government, etc., to be able to manage cybersecurity better. And our claim to fame, that's why we started Skybox, was to use modeling simulation technologies that can be applied on to a day-to-day security management processes in order to be able to reduce risks before the organization is being hit with potential attacks. So that's how we started, and that's who we are. We are going to discuss today a few different related topics. One, to cover a bit the landscape of cybersecurity threats, discuss the importance of risk management processes to be able to manage cybersecurity threats, discuss different options of how to manage security risk on a proactive basis, and then drill down more to why modeling simulation technology is so critical to be able to do it in a very cost-effective way. So that's what we're going to discuss today. If there are any questions, comments, or whatever along the presentation, just raise your hand or ask. If it's going to be relevant, I'll answer or relate to it immediately. If not, we can cover other questions at the end, and we'll leave just a few minutes available for that. So I think I covered already Skybox. I'm not going to relate to that again. Again, serving primarily large enterprises, government agencies, US, Europe, in other places, typically in their combat against cybersecurity threats. Skybox just is one background because I don't know how many of you know about Skybox. I'm not going to cover everything we do. Actually, I'm not going to cover what Skybox does. Of course, I'll share with you experience of dealing with cybersecurity. And we're going to focus specifically on one set areas of focus that Skybox has, which is called Skybox Risk Control. So it's solutions for security risk management, again, using the modeling simulation technologies that we are going to cover today. I'm not going to discuss other areas that, if some of you know about Skybox, is dealing with, like network assurance, firewall assurance, and other processes that relate to network security. That's not going to be the scope of today. If there are more questions, you can get to our website or ask me later. So let's start with managing security risks. Hopefully it's visible. So traditionally, if you're looking, let's say, in the last 20 years, when information security business started with the first antivirus solutions, first firewall solutions, so in the first 10, maybe 12 years, it was all about putting more security controls. So let's say if I have more security issue, I'll buy more software or more hardware that hopefully prevents from spamming, viruses, worms, intrusion that can be prevented on the network security level, like firewalls, intrusion prevention systems, and many other stuff. So that's security. What happened along the years, it was clear to everyone that that's not enough. I mean, you can buy a firewall, put it in your network, and actually you're going to be insecure as much as you were before. It's even worse because you think you're secure because you put a firewall on an antivirus solution, but if it's not configured properly, or the antivirus, let's say, is not updated, it just doesn't help you at all. Okay? So what happened is that there were a lot of investment in security solutions. There was a growing faulty sense of security that was irrelevant because attacks just accumulated more and more, and organizations started to understand that's not enough. So of course they need security solutions, but something has to be managed here. So then came a new set of solutions that, after seeing that that's an issue, that actually tried to deal with the security incidents after they happened. So it's a space which is called SIEM, or Security Information Event Management. And these products are getting logs and events from all of the security solutions, systems, routers, whatever you want, correlate them, and try to tell you what happened. And if you caught it on time, try to help the organization to contain the potential attack. So that sounds great, and since let's say about 10, 12 years ago, there was emergence of different solutions, and different companies start to provide solutions in that space. Definitely needed, right? If something is going on, you want to catch the attack and deal with it. The issue is that in most of the cases, in sophisticated attack nowadays, that's way too late. Or what some of our customers say, real time is too late. Why is that? Because a lot of the attacks are slow and not really detectable. And once you really detect them and deal with them, the intrusion probably has happened. The damage was already happening before then. Okay? So despite the fact to deal with incidents after they happen is important, that's not enough. Again, there are lots of false positives, too much information, it's way too late. Okay? So when Skybox started and then followed some other companies, we said, okay, security controls, of course, are needed. Security monitoring after the fact is definitely needed. If someone intrudes your house, definitely want to know about that. But it's not enough. And we thought that if we can provide the right solutions before the attack happens, then actually we can help organizations to save a lot of the trouble they are running into on a daily basis. So what Skybox invented is a new space, again, when we started in 2002, which is called security risk management. And the space is all about understanding what may go wrong, what's the risk of that going wrong, what might be the consequence of those potential attacks or incidents, and how to avoid them up front without the need to wait for the successful prevention of the attack by the security controls or the monitoring solutions that are looking at the attack after it happened. Okay? So along the years, we've seen that there are lots of things under that title, security risk management, but what's common to all of that they are helping organizations to deal with the attack before it happened. Okay, so basically predictive capabilities to understand exposure and to drive mitigation before the damage is been done. So what's the context for security risk management and why it's becoming more and more important? It's because of multiple reasons. One, there is significant rise of theft of critical information. It can be intellectual property, it can be patents, it can be secret academic work for government deals, it can be credit card information, healthcare records, and all of the above. And what happens is there are more and more attacks and more ways for attackers to actually use the information and actually make money by stealing the data. So it's not just hackers that enjoy penetrating a system like it was 10 or 15 years ago. There are professional crime organizations that steal data in order to make money out of it. Okay? And the amount of attacks is growing, the visibility of those attacks are growing, and therefore organizations understand that probably what they invested over the last 20 years in security, both security controls and security monitoring, is just not enough. The risks are still there and are materialized. Second element is the disruption of critical services. So what happened over the last 2 years that, again, due to cyber terrorism, cyber warfare, and the criminal activity that we just discussed, there are more and more attacks on critical infrastructure, which means utility companies and power production, maybe government services, defense agencies, and lots of other stuff. So there were some notable attacks last year that put a few days down some of the Brazilian utility companies. There were attacks as part of conflicts around Estonia that actually put all of the defense agencies' networks down as part of a warfare activity. So that started to become a huge issue for anyone who deals with critical infrastructure, government, utilities, telecommunication, financial services, and others. So all of those issues actually raise the visibility for risk management, which if it was, let's say, an optional activity until a couple of years ago for the more advanced organizations, most of the organizations today understand that they need to start implementing risk management processes, and the best way to do it is with technology that can actually automate them in a scalable way. So what's a typical security risk management process? And there are lots of different variations for that, so, and all of them are quite similar to each other. So it's all about understanding what you have, like understanding what kind of assets, networks you have, what are the critical information you want to protect. So let's call it mapping. It's about understanding what are the potential exposures that you might have. We'll discuss later how to do that. So the fact that I have assets and vulnerabilities doesn't mean that someone can attack me. So let's say if I have a house, let's say, and I left the window open, maybe I have a guard after the window, so people cannot really get through that. So the fact I have vulnerability doesn't mean automatically there is a critical exposure. So risk assessment. Prioritization, so understanding, okay, what's really critical, because I can tell you, our experience working with a lot of the largest organizations on earth, there are millions of issues in every organization, millions, not few, not thousands, millions. But not all of them are that important. So prioritization and understanding what's the best way to deal with those critical issues and to be able to track it is critical in order to close the cycle in an effective way. Okay? So that cycle, which seems to be probably logical to anyone that manages risk, security, financial risk, operational risk, or whatever, it will make sense to. The challenge is how to implement it in a cost-effective way. So think about that. So let's say if you try to do this entire cycle, and you try to run it, let's say, every year. So let's say you hire some security consultants, or you'll have a project, you try to assess the risk of, let's say, the campus network, and it will take you a year to conclude what's the issue. So along this time, you have a big window of exposure. A lot of people can attack the network until you come with the conclusions and deal with them. So therefore, to conduct this cycle, let's say every 1 year, doesn't help you a lot. To do it every 3 months, it's slightly better, but still you have a big window of exposure until you are done and remediating everything which is critical, the organization is exposed. So there is, in other words, there's a direct correlation between the frequency of the cycle and the risk level. The higher the frequency, the lower the risk can be, right? Because you can limit the window of exposure. But of course, there is a challenge, right? Every time you run a cycle like that, it can be very costly, very timely, and therefore organization cannot do it so often. So that's the biggest challenge here. So if you're looking on one alternative, let's call it the manual process. So you can say after this presentation today, you can say, I want to implement security risk management. I want to do this process, but if you do it manually, it will take you, let's say, a quarter or 6 months to perform one cycle. During the cycle, until you remediate the key issues, actually the risk is going up, right? Because you have exposures, people can penetrate, and while you're working on the document, trying to understand what's going on. You reduce a bit the risk, and then let's say in 6 months or 3 months or whatever, the risk will go up again until you are basically ready to do the next cycle of remediation. So what happens is that despite the fact organizations start to use security risk management methodologies, not only to spend time and money on that, but actually the risk went up and not down along the time. Make sense? So the concept, that's why basically we started Skybox. We said, okay, we didn't invent risk management, but what we invented is automated technology to actually make the cycle as frequently as needed, daily, hourly, weekly, or whatever, because it's automated, so you can run in a frequency. And if this is the case, actually you can reduce the risks along the way, right? You can have frequent cycles. In every cycle like that, you have a very controlled level of risk. You know very quickly about the critical exposure. So let's say, I don't know how many of you are following newsletters about security, but let's say there's something which is called Patch Tuesday. So every few Tuesdays, Microsoft is announcing about a new list of vulnerabilities that their software is vulnerable to. Okay? So a couple of days ago, last Tuesday, there were about 50 new vulnerabilities. So think about your organization, let's say. Maybe it was perfect, right? Zero risk until 2 days ago. But suddenly, the entire world knows about a lot of new vulnerabilities that are exploitable on Microsoft software, let's say in that case. So automatically the risk will be up, right? If it will take you 3 months to deal with that, the risk will go significantly and probably will be attacked until then. If you know about that very quickly, you know what are the critical exposures, and you have the chance to deal with them before you are being exploited, you can actually reduce the risk and maintain it in a very cost-effective way. Okay? So that's basically the rationale why automated solution is needed. You can increase the frequency and actually reduce the risk at the same time. Make sense so far? Okay, so let's discuss very quickly how do you kind of manage risk. And this is not a mathematical definition of risk, it's more conceptual, but I think it will give the story of how to deal with risks. So if you're looking at the key 3 factors, and of course it's not really multiplication, just a combination of those factors are 3. One, the threats, right? If no one wants to attack us, probably we don't have any risk even if we leave the windows open, right? So we have threats that are a major factor on calculating risk. There are vulnerabilities, so maybe kind of bad guys wants to attack us, but if everything is protected so well, probably the risk will be low. If we have some windows open and someone wants to intrude our house, probably the risk will be higher. And the third element is, of course, the consequence. Right, so we may have systems which are vulnerable, but they are just test systems. Attackers may want to attack them, but actually there is no critical information in those systems. They don't have any mission-critical project they are supporting, so probably the risk is not very high. So basically there are 3 main factors. Again, the threats, the vulnerabilities, and consequence combined together are actually contributing to the risk. So let's see how to reduce risk. So there are probably 3 options, right? We can either reduce the consequence, we can reduce the threats, or reduce the vulnerabilities. So let's start with the consequence. So naturally, typically security operation does not change the consequence of the attack, right? If there's a critical system, let's say support power supply to Sonoma County, it's needed, right? Even if there are some risk in putting it down, putting down the energy supply is probably worse than a potential attack by some cyber attacker, right? So security operation does not really deal with the consequence. It's the consequence is what needed for the business. If it's an important system, you need a system. If it's not important anyway. So the consequence is not dealt by security, it can be dealt by whoever owns the systems themselves. Second option is to deal with the threats. But again, unless you are part of, let's say, the offensive part of the US military, let's say, that you can attack the attackers, the rest of the world does not attack the attackers. The rest of the world just suffer the consequence of potential attacks. So the fact there are threats out there are probably out of your control. You're not going to fight against them, again, unless you are some kind of law enforcement agency or military operation or whatever, which probably you are not. You cannot deal really with the threats. So what you're left with is actually the vulnerabilities, right? So this is the third factor. And that's completely controllable by the IT operation or security operation of the company, right? So you can reduce vulnerabilities. There are plenty of them, so we discuss part of the challenges of how to deal with that. And that's why we need security risk management methodologies. But basically, if you focus on reduction of vulnerabilities, even if there are threats out there, or there's potential bad consequence of the attack, but you reduce the vulnerabilities of your network, actually you can reduce the risk dramatically. And that's the control variable that you can impact, basically. So let's discuss the reduction of critical vulnerabilities. So what's the challenge? The challenge is that there are plenty of them. As I mentioned just a couple of days ago, let's say 50 or so new Microsoft vulnerabilities. That's on top of many thousands that were reported over the last few years. So today there are about 6,600 or so newly discovered vulnerabilities just in 2009, and it's actually growing. So think about that. If you're looking in the last 15 years, every year there are more and more vulnerabilities which are being reported on software, hardware, whatever. So not only you have kind of a lot from previous years, you have many more coming every week, hundreds a week, right? If you divide 6,600 by, let's say, 50 weeks, you have about 100 plus a week. And actually, the trend is actually getting higher and higher all the time. So there are plenty of vulnerabilities out there that are all the time discovered. If you're looking on a typical network, just to give you some other kind of statistical data, every system, host, desktop, notebook, whatever on a network, typically has between 20 to 100 vulnerabilities. So different instances of different issues that are potentially exploitable by someone bad. Okay? So let's say if you have a network of, let's say, probably this campus have whatever, 10, 20,000 nodes, right, I assume. On that ballpark, multiply by 50 vulnerabilities per node, 50 issues per node, and you have kind of 500,000 issues just in this campus. Okay? Not all of them are critical. Some of them are less. That's part of the challenge. But there are plenty of vulnerabilities out there, and the challenge, the complexity of the analysis is that, one, you don't know which one is really exploitable, right? I'm sure that you have firewalls and maybe some other stuff, so not everything, every vulnerability you might have is really exploitable by some attacker. Okay? So to know what's really exploitable, given your complex network, security controls, etc., is a big question. Second question, are there the right countermeasures to prevent attacks? So it might be something is exploitable, but you have some intrusion prevention system that looks on different signatures of attacks and block the attack as it's going, and maybe you are fine, the risk is not that high. So to understand the correlation between the countermeasures, the security controls, vulnerabilities, exploitation is a big question. What is the potential damage? Another question. So the fact something is exploitable and maybe you don't have any protection mechanism against this exploitation doesn't mean it will lead to a serious damage. Very tough to know, very tough to analyze. So the challenge is with so much data in complex networks, to answer those questions proactively and fast, let's say daily or weekly, takes a lot of time. Okay? While the only good news here, hopefully you see that at the back rows, that what we found while serving a lot of large organizations is that actually the amount of vulnerabilities organizations really need to fix is about 1 or 2% of the entire set of vulnerabilities. Why is that? Because many vulnerabilities are leading to non-critical attacks. Many vulnerabilities are mitigated by potential security controls you have in place, like firewalls, intrusion prevention systems, and others. So at the end of the day, if you answer all of those questions, you find actually 98% of the vulnerabilities are not that critical to fix. But what it means is that the 1 or 2% which are left are probably very critical, and the sooner you know about them, the sooner you fix them, the safer you are. So let's go back to why we started Skybox. So our big aha was that if there's only fraction of vulnerabilities that need to be fixed, and in order to know this fraction, we need to understand potential exploitation. We need to understand countermeasures in terms of security controls, and we need to do it fast. Maybe there's some technological ideas of how to do it well. And our concept was that if we can create some virtual model of the way the network behaves, security controls behaves, and we can simulate attacks like intruders, attackers will try to conduct on your network by simulation in a virtual model. One, potentially we can do it very fast, right? Because simulation, as long as it's not exponential algorithms, can be probably faster than a human being reviewing all of the possible vulnerabilities, entrance points, and all of that stuff. And they come with conclusions very fast of what's really exploitable, right? If we find some way to, by simulation, that an intruder from the outside, the inside, or any point of origin can exploit different vulnerabilities, given everything you know about the network, then probably those vulnerabilities are really critical to fix. If we found that there are some vulnerabilities which are not exploitable as a result of the simulation, maybe they're not critical, because someone in the real environment cannot really exploit them. And that was the concept. So that's how we started our journey back in 2002 and developed the first modeling and simulation technology for cybersecurity in order to be able to know really if an organization can really be penetrated, how the penetration works, what's the best way to prevent it in a proactive way. Okay? So the concept was, let's have a modeling technology that can understand how the network works, security controls work, about every vulnerability I mentioned. There's a lot of information about them, what's the exploitation requirements, what's the consequence of exploitation, a lot of data that is required in order to be able to simulate potential attacks. So that's one. Second element of the innovation here was that we can find all possible attack paths based on simulation technology, which we will demonstrate by a couple of slides soon. And the third element is that if we know how to exploit and we can demonstrate what are the potential attack vectors, then actually automatically we can recommend what are the right remediation, what are the action items to prevent those attacks from happening. So maybe we can tell the organization if you change one port or one rule in your firewall, actually you can prevent an attack and maybe reduce the need to patch 50 systems, let's say, etc., etc. So there are a lot of different ways to how to prevent attacks, but the idea is that if you know exactly how to attack, maybe you know how to prevent the attack as well. And that was the whole concept of where we started Skybox. So again, the big challenge is that it's the needle in the haystack issue, right? So many vulnerabilities, little time to deal with that. And the concept was in terms of simulation. So we said, okay, we want to find attack scenarios. We know that we need to model the environment, but the question is how to do that. So what we did, we actually looked on technologies that use similar modeling simulation concepts, but in completely other domains. Like in a kind of a piloting simulation, kind of basically simulating how to pilot a plane, how to take it down, whatever. There are a lot of simulation that you're using there. Why is that? Because you don't want pilots in the first time to actually try and crash kind of a real airplane. It's a bit costly and dangerous even. So that's an example. There are also kind of training for medical surgeries, that with modeling and simulation, you can actually train people without the need to, for the first time, try it on a live person, for example. Think about weather forecasting, where you have a lot of data, and what you try to do is predict the future, right? So you try to understand, to create some model of everything, right, about the climate and what's going on, in order to predict what's going to be the temperature, or where the hurricane will land, or whatever, requires similar capabilities, etc. So I think you got the story. So we said, okay, if we can develop the right simulation technology for cybersecurity, maybe we can solve a lot of those issues in a very similar way. So again, what's the benefit similarly to surgery, piloting a plane, hurricane prediction, and all of that stuff? The value in cybersecurity of simulation is as follows. One, you can assess the risk without impacting live network, right? You can run the full set of attacks scenarios, let's say, based on a virtual model without sending one packet in the network, so you actually don't try to really put systems down, which are critical. You can evaluate tons of combinations, of course, only if the algorithms are scalable. You can evaluate basically infinite amount of combinations almost of potential attacks and remediation. You can perform it very frequently, as we discussed. In order to reduce the risk, you need to do it every day or every week as opposed to every year. you can predict and rank a lot of different scenarios, even not real scenarios. So you can consider scenarios that you haven't seen before. So think about just imagining using modeling simulation technology. I mentioned earlier attacking the attackers, and where you want to, let's say, model, let's say, adversary networks, for example, for defensive or offensive use. So there are lots of things that you may do by actually using modeling technology and actually create scenarios which are not real, or potential real, or future scenarios, or analyze past scenarios, and you don't need to deal only with the current situation. Okay, so a lot of benefit for such capability. So let's start with let's start with the modeling aspect. So what is cybersecurity modeling? It's basically a normalized view of the cybersecurity situation. And if you're looking on the network infrastructure, it means a few things. It means understanding the network infrastructure and its topology, and where are the security controls, like firewalls, intrusion prevention systems, and other security controls, understanding how they're being configured, understanding where the vulnerabilities, okay, and you have plenty, right? You might have hundreds of thousands or millions, so we have to understand specifically what are the vulnerabilities that you have on every host. We need to understand what are the critical systems that are really we want to protect, right? Well, the consequence can be the worst of potential attacks. We need to understand the threats. Who wants to attack you? So there's a lot of information that you want to understand together and normalize. All of it together is what we call cybersecurity modeling. And you need to visualize that and do it on an ongoing basis, right? If you model only once and you don't update that, so you can run risk assessment again and again, but it's not going to be current to your current situation. So of course, continuously updating this virtual model of the cybersecurity situation is critical. So let's show an example. So think about this kind of network as a battlefield and what you may know about it while you gather information. So you may know about, let's say in this area might be some critical assets that you want to protect, right? These are the ones we care about the consequence of potential attack. So you can understand where some critical assets, critical networks may exist. You can then understand potentially where you may have gaps in defenses. So you can understand, this actually little icon stands for a firewall, let's say. So you can understand where are the firewalls and routers and all of them and how they are configured and to see if they are really configured properly. You can understand potentially where the source of attacks. So probably one source of attack is the internet, because a lot of the attack starts there. But you may have connection to some other, let's say, university, and potential attacks can come from there, or some partner network, or from within the university, or wherever. So you have to understand, to map where are the potential threat origins to your IT infrastructure. So all of those pieces of information, including all of the details about that, are part of the modeling and visualization of that. Okay. The biggest question we want to ask ourselves, right, is, okay, can someone attack us, and what can we do about that, right, given this understanding of the security situation? So do we have the right countermeasures, or what kind of countermeasures are required? So for that, as we said, there is the need for this attack simulation technology that actually finds all of the possible attack vectors on your network from any source of any origin, basically, in order to find what's really, really critical, right? The few vulnerabilities which are, if exploitable, can get to a very significant damage. So we're not going to discuss, we have probably 10 more minutes, so we're not going to discuss how attack simulation algorithmically works. If you want, we can chat about it later. But let's see an example for a result of a simulation. So what you see here is an example of a direct graph that shows an attack that starts from the internet, and in actually multiple steps exploit different vulnerabilities in order to, let's say, affect some consumer's billing application of some, let's say, utility company, for example. So this shows a recipe of how to attack, let's say, this utility or power kind of a producer network in multiple steps. So it's really a recipe. If an attacker would look at it, will know how to penetrate the network, let's say. So for example, in this case, we show that the internet hacker can actually exploit some FTP vulnerability, gain some root control over this host, and actually use it as a base to continue the attack on and exploiting two other vulnerabilities on other systems, which the consumer's billing application depends on. Right? So it gives you kind of a recipe of basically how to get from point A to point B. Very similar to planning algorithms. If any one of you learned about planning robots routes and stuff like that, if you have some constraints of a terrain, you want to understand how to get from point A to point B, given that it's very, very similar type of algorithms. So the result of that, we can show how it's possible to attack not only from the internet to the consumer's billing application, but actually all of the combinations of all of the threat origin, starting points of attacks, towards any system that you have in the network and find all of the possible attack scenarios. And demonstrating either visually or by some other means we can discuss later, what are all of the possible kind of vulnerable entrance points of the organization. We can also show which vulnerabilities out of the millions that you have really contribute to one attack or another. So as we said earlier, the majority of the vulnerabilities won't be included in any attack scenario, right? Because there are firewalls, intrusion prevention systems, or other things related to the network topology that prevents exploitation. So actually, even just by looking on all of the list of attack scenarios and actually just summing up all of the vulnerabilities that contribute or participate in one or more attack, we already can reduce the amount of work significantly by actually creating a very short list of action items. Okay? More than that, remember what we discussed earlier about risks, right? We have to understand threats, we have to understand vulnerabilities, and what's exploitable, and we have to understand the consequence. So now we know about the consequence, right? We know that it's possible to attack the billing, a consumer billing application, and if it's critical, the risk should be high. If actually this application is not very important, let's say, then maybe the risk is not very high, and those vulnerabilities are not really at the top of the list to be mitigated. Okay? So that shows, to give you some kind of hints, how attack scenario information can be used both to quantify risk, right? We know threats, vulnerabilities, and consequence, and we can, in different formulas, basically quantify a risk metric. We can guide the organization of what vulnerabilities are actually contributing to attacks, and therefore knowing where to put our efforts on, right? As opposed to deal with a million vulnerabilities, let's deal with 10,000, or instead of 100,000, deal with 1,000. So that's one. And second, we can get some good ideas of actually how to mitigate those potential attacks. So we'll discuss it in the next couple of slides. So let's take an example, this type of attack, or very similar to that. So let's say we found this attack scenario, and we can see that it's possible to get from different zones, from one zone of the network to another, like internet, right, as a zone, maybe to some DMZ zone, so the zone where you have typically web servers, and from there to get to the, let's say, to the data center itself. So between those zones, typically you have routers and firewalls and devices like that. So you can say to yourself, maybe instead of patching all of those systems, and remember this is just an example of a small, easy attack scenario, it might be tons of nodes that can be exploitable, maybe instead of patching all of them, you can just break one of those edges on the graph, right? And let's say if there's a firewall between point A to point B here, you don't see it here, but behind this arrow, actually we may be able to just change the configuration of this firewall and block this attack completely. If it has so many hosts participating in the attack, maybe it's going to be way cheaper to change one firewall rule configuration instead of patching, let's say, 50 different systems. So there are lots of conclusions you can get out of that. For example, as we said here, you can see that, I don't know how many of you know networking and traceroute and how traffic flows in the network, but this shows just the different hops. One connection in the network can go through, let's say, the internet, through different routers and firewalls, and get to the destination, which is this host in that case here. Okay? So maybe instead of patching this host, we now know what are the routers and firewalls we may want to change the configuration to block this potential attack vector. Okay? So that's just kind of a very immediate action item that can be derived out of attack scenarios. On the other hand, we know that there is a kind of high business impact for these potential financiers, and we may decide, for example, in this case, just to maybe patch the Cold Fusion server. It's just kind of application server that supports this application. And if we do that, we almost don't care if something else is exploitable in the network. We know that we protect the right asset, and therefore attacks on this asset won't be possible. So that's kind of another alternative. Okay? So there always can be a lot of different alternatives for mitigating attacks. The beauty of that, of those finding attack scenarios, that you can limit the list significantly of where you need to look at. You can understand what's the consequence of attacks and understand, therefore, to prioritize and actually understand what you really need to deal with as opposed to a nice to have to deal with. And actually you can derive, as we said here, the right type of action items from those potential attack vectors to find the most effective way to close the attack now, or to close a potential attack now before you're actually being attacked. Make sense? So if you remember what we discussed earlier, that the critical success factor in reducing the risk is to have a high-frequency process that assesses the risk, the exposures, before you're being attacked, and close the most critical attacks before the exploitation. So if you know the potential vulnerabilities, you understand very quickly what are the exposures, what are the critical ones, and you can find the most effective way to remediate, actually you have now ingredients for a very automated, very fast risk management process. So let's say just maybe summarize quickly. So we discussed earlier the different, let's say, scenarios, company A, company B, or 1 and 2, where one is very slow process, very, let's say, every 3 months or 6 months to assess risk and deal with it. And at the end of the day, this company is spending a lot of money, and actually the risk is rising along the way because of a large window of exposure that lets intruders get in, despite the attempts and the wish to reduce the risk. Versus a second situation where you have a high-frequency process that actually can reduce the risk because you can actually close the most critical attack scenarios before they're being attacked, before they're being exploited by potential intruders. So that's basically what we've seen is many organizations now adopting in order to reduce risk in actually a very cost-effective way. Okay. Let's discuss maybe some of the other elements of risk management, some of the, let's say, business benefits in addition to just the pure security benefits, again, of a risk management process. So think about what we discussed earlier about critical infrastructure. So if you have critical infrastructure like you're a utility company or financial services or stock exchange or government agency with critical services, at least some of what the government does is critical, then security is important, but also availability of those services. Part of the issue of managing IT networks is how to balance security requirements and availability requirements. So now if you have a way to understand what's the consequence of a change, you can use this understanding not only to understand the consequence of a security-driven change, but availability-driven change as well. Think about a situation, someone may add some more rules to a firewall to prevent certain access in order to prevent exploitation of some critical vulnerabilities. But what if this actually new rules actually prevent some critical business service to operate, right? So we affected some availability of some critical business service. Modeling and simulation technology can actually be used for both and actually balance the needs of security and continuity of business service availability of the network at the same time. So that's very critical, again, for any critical infrastructure operation. Second element is about reduction of patches. So I discuss all the time and use terms like attacks and threats and risk and vulnerabilities, which are very security-driven terms. But most of the work in order to fix security issues actually is not done by security teams in organizations, are done by system administrators, by firewall administrators, and others are part of IT operations. So for security to throw on them a long list of action items or even a shorter list of action items is not necessarily accepted very well. Part of the value for IT operations to use security risk management is actually they can reduce significantly the amount of work they have. Right, so if a system administrator can actually patch way less systems, or a firewall administrator can reduce significantly the amount of changes they can do, we make their life easier as well, and not just the organization more safe. Okay? So another important thing, especially in the last couple of years with the recession, that IT organizations became, the resource for IT organizations became more and more scarce, and the ability to automate both the security elements of risk assessment and reduce the workload in IT operations in patching, network changes, etc., is a huge benefit. So the ability to free up IT resources become more and more critical. The last element, which I didn't touch at all today with, is related to regulatory compliance requirements. So over the last decade, and especially over the last 2-3 years, there are more and more regulations that regulate specifically how security needs to work. So they are telling security organizations what kind of security controls they should put in place and what kind of management process they should have in place. And the security organization need to show that they are doing all of that. So it's not just about we want to be more secure, but we need to do those processes because regulators ask us to do that. So the result of all of that is way more work. And with the automated solution where you can automate all of those tasks of risk assessment, remediation, demonstrating that what you do is not just good for security, but good also for compliance, actually there's significant saving to organizations. Okay? So this is kind of the 4 highlights of business benefits that I want to mention as related to security risk management. And I think we have 3-4 more minutes, George, right? Yeah. For if there are any questions, comments. Yeah, please.
What would you say the percentage of attacks or viruses are caused by the same companies that or hard to fix them?
That's a good question. I think it's very marginal. I think there's so many attacks that are now running by independent people that just wants to steal data, disrupt services, that the industry is big enough without those companies, let's say, effort. The need for the effort to actually contribute to the industry itself.
How do you generate the model? Do you install like client software on all the workstations and servers?
No, so the way we do that is actually we collect information without any agent at all from typically existing information sources within the organization. So let's say results of vulnerability scanners, or let's say get into the files and routers and grab the configuration, or grab it from some offline repository that may store the configuration. So there are lots of ways to get the data. Typically what we found is that most of the data exists. The challenge is to put it together, normalize that, simulate it, etc., so to put it to work for security risk management. Other questions? Comments?
So kind of on his question, I guess, do you have like a hardware box that you run like on someone's network if you're doing auditing to collect network traffic?
Yes, so we don't collect traffic because remember it's a proactive solution, so the traffic is not there yet, right? You want to understand what may go wrong, not what went wrong. But there are multiple ways to use technology like that. Most of our customers are actually using that. They are taking either Skybox software, install it on a server, or buy our clients, same basically, put it in the network, collect the data, on an ongoing basis, get alerts, reports, or whatever with all of the findings of the analytics that we have. So that's one way to do that. Second way is actually to use it on a notebook, right? So you can run on a notebook. It doesn't have to be in a large-scale network, and actually can be used by security assessment or security auditors that can grab the data or get it offline completely, load it on the notebook, do the analytics, which is pretty simple because it's automated, and actually send the report back to the organization and charge a lot of money for that. Okay? So there are multiple ways to use that, and actually there are some other ways, but these are typical two ways of using software like that.
Gidi, is the 1 or 2% that you mentioned that include social engineering as well?
So in general, yes. I can tell you that specifically Skybox in our modeling is typically dealing with the IT infrastructure itself. So the statistics that we have are based on actual customer data, a lot of that are dealing with the, let's call it the infrastructure vulnerabilities. What we've seen in other space like application level or social network vulnerabilities or whatever, it's very similar ratio, especially if there are decent amount of security controls in the network. It's never perfect, but typically even decent amount of security controls in the network protects the organization from the majority of the exploitations. But again, there's always a very long tail of vulnerabilities that if exploited can get to serious damage. So let's say at least our experience in that.
Any other questions?
Yes?
When you do the proactive or predictive, then do you have a mechanism to, how can I say, also look to see what the results are and how effective was it?
Yes, so part of the beauty of running that modeling simulation on an ongoing basis, that actually we keep track of all of that. So in a sense, we manage the life cycle, or understand the life cycle of those vulnerabilities. Once they found, assessed, mitigated, if the mitigation worked or not, we can assess that as well, and understand whether it was really close at the end. So the fact that we do it on an ongoing basis, or let's say daily or on a similar frequency, allows the automated tracking of what happened and not just what will happen.
And then will your model adapt to it? For example, the 2% set may change over time. You may find it to be different over time.
Sure. Yes, so the way it's working at Skybox, we have the analytic engine, the simulation engine we actually have two sources of information. One is the virtual model that we just mentioned, right? The network, vulnerabilities, everything that we can know about the organization. Second source of data, which I didn't mention, is actually content updates provided from Skybox with all of the new attack vectors, right? So let's say, we mentioned earlier, let's say new vulnerabilities announced by Microsoft or Adobe or whatever, doesn't matter who, that we are creating actually, let's call it an interpretation for simulation purposes of every new vulnerability that is being published and feeding that automatically to our servers as well, okay? So when we do simulation, we have the most freshest understanding of the organization network by this virtual modeling. We have the freshest understanding of all of the possible attack vectors based on the feed that they get from Skybox, and those two sources work together as part for the simulation.